Hello everyone, welcome to my YouTube channel. Today we will solve the questions from SLET 2023 complex analysis part. So in question number 17, it is given that if f of z is analytic within one circle C mod of z minus a equals to r and f of z is less than or equals to m, then for every z on C, which option is correct? So see, the options are given in mod of fn a. So we know what is the formula for fn of a is equals to factorial n by twice pi I integral around C f of z divided by z minus of a whole to the power n plus 1 dz. This was the formula. Now we have to find mod of fn a. So take mod on both sides. So this will be factorial n divided by twice pi integral around C. This is mod of f of z divided by z minus a whole to the power of n plus 1 this dz. So this will be factorial n divided by twice pi. So this will be less than equals to, since it is given that f of z is less than equals to m, so this will be m, and this z minus a is r, so it will be r to the power of n plus 1, then integral around C this dz. So this will be less than equals to factorial n divided by twice pi m r to the power n plus 1, and integral around this will be 2 pi r. So finally the answer will be factorial n m divided by r to the power n. So this will be less than equals to. So therefore fn mod of fn a less than equals to m factorial n divided by r to the power n. Option B will be correct. So let's see question number 18. The next question is, let C be the positively oriented circle with center at origin O and radius smaller than 1. Then consider the following statement, assertion and the reason. Assertion is integral of this equals to 2 pi I, and reason is f of z equals to this. So let's analyze the question. What is given? It is given that the radius is smaller than a1, that means mod z is less than 1. So the circle will be, this is the circle with radius 1, center at 0. Now find the singularity from here. So what will be the singularity here? Z minus of z square is equals to 0. So take z as common. This will be 1 minus of z equals to 0. So from here either z equals to 0 and z equals to 1. So since it is says that mod z is strictly less than 1, so 1 is not included in this region. So integral around this will be 0. So we'll only consider z equals to 0. So the integral will be e to the power z into 1 minus of z dz. This will be equals to twice pi I. So our f of z will be this one. This will be our f of z, and we'll put z equals to 0 here. So f of 0 will be e raised to the power 0, 1 minus of, this is 0, and e raised to the power 0 is, so this is final answer is 2 pi I. So assertion is true, and the reason is f of z is this. Since we have also here see our f of z will be this, so reason is also true. It is given that this f of z is holomorphic on a simply connected open set U containing C, so it is correct, and 0 containing 0 of 1 minus z by Cauchy integral formula, we have the assertion, so it is also true. So the correct option will be in option A. Both assertion and reason are correct, but R is correct, and R is correct explanation of assertion, so option A will be correct. The next question is, consider the following statement, f of z equals to real part of z is continuous for every value of z, and B is f of z equals to imaginary part of z is continuous for every value of z, f of z equals to z bar is continuous for every value of z, and D is f of z equals to z bar is differentiable at z equals to 0. So now we have to choose the correct answer from the code below. So let's see first option D, f of z equals to z bar. So we know f of z equals to z bar is nowhere differentiable. Nowhere differentiable. So it says that f of z equals to z bar is differentiable. So option D is false. Option D is false. Why this is not nowhere differentiable? Because del f upon del z bar is equals to 1, not equals to 0. So CR complex form of CR is not satisfied. Therefore, f of z equals to z bar is nowhere differentiable. So it says option D is true. So this one option will be cancelled. This is also true. Will be cancelled. Now the correct answer will be either C or D. So let's see other options also. So in A it says that f of z is real part of z is continuous for every value of z. So if you consider f of z is constant function, so real part of z will be continuous. So option A is true. Option B is also, if you consider f of z is constant, then the imaginary part of z will be also continuous. So this is true, and this is also f of z equals to z bar. So z bar means x minus of iy. So we know z equals to ux plus ivy. This f of z is continuous if ux and vy is continuous. See, ux is continuous, vy is also continuous, so f of z is will be also continuous. So option C is also true. True, false. So let's see, true, false. True, false. So option C will be correct. So the next question is, we have to find the radius of convergence of this series. If the radius of convergence of this series is r, then the radius of convergence of this series, we have to find the radius of convergence of this series. So how to find the radius of convergence of this series? So let's consider this is Cn. So we will find limit supremum of Cn whole to the power 1 by n. This is equals to 1 by r. So from this formula we will find the radius of convergence. So lim sup of, what is Cn? Cn is this 2 to the power n minus 1 and then an. So using the lim sup formula, we can write this as lim sup of mod of 2 to the power n minus 1 into lim sup of, this is whole to the power 1 by n whole to the power 1 by n, an whole to the power 1 by n. And since 2 to the power n minus 1, this is almost similar to 2 to the power n, we can write it as 2 to the power n. So lim sup of, this is 2 to the power n whole to the power 1 by n. And what is this? This is the radius of convergence of this series r. It is given that it is r. So what will be the value of this? This will be 1 by r. And this 2 and 2 is cancel, and this n is n cancel. So lim sup of this mod of 2 will be 2. The answer will be 2 by r. So 2 by r equals to, this is r dash, let r dash. So the radius of convergence r dash will be 1 upon 2 by r, that means r by 2. So in option D it is given that r by 2, option D is correct. So the next question is, let f is from C to CB analytic such that f of 1 by n equals to 1 by n square for n equals to 1, 2 and so on. Then f is bounded f of z equals to 2z, f of z equals to z square, f of z equals to z, which is correct. So in this type of questions, let's consider 1 by n equals to z. So f of z will be equals to z square for all z in C. Option C is correct. See the question number 57. So in 57 it is said that consider the following two statements. Every function analytic in the extended plane is constant. So extended plane means C union infinity, and we know that entire function that remains analytic at infinity also, this is only the constant function. So this is the properties of Liouville's theorem. So option 1 is true. And option 2, it is given that if f of z is entire and such that f of z equals to u plus ib and u square plus b square less than equals to 2016, then f of z is constant. So we know Liouville's theorem is if f is entire plus bounded, then this implies f is constant. This is nothing but the Liouville's theorem. So here this is nothing but this means that f is bounded, and it is given that f is entire, so bounded plus entire, then f is constant. So this option also correct. So correct option will be option B. So the next question is, consider the following assertion. The residue of f of z at z equals to 0 is 1 by 2009 factorial, and f of z has a pole of order 2009 at z equals to 0. So the assertion is, we have to find the residue at z equals to 0. So what is the formula for residue? Residue of f of z is equals to 1 upon n minus 1 factorial t z of n minus 1 of, so this is z minus a is, this is 0, so z to the power n is z to the power n f of z. So here the order of pole is 2010, so this will be 1 by 2009 factorial t of, this is 2009 dz of 2009, and this will be z to the power 2010 into sin z divided by z to the power 2010. So this will be cancelled out. So 2009 factorial and the differentiation of this z. Now if we differentiate 1 times, then this will be cos of z, and at limit z tending to 0, now there will be limit z tending to 0, and cos 0 will be 1. So for again, if we again differentiate it second time, this will be sin z, and sin 0 will be 0. So for even, the differential will be 0, and for odd times the differential will be 1. So since here this is 2009 is odd, so odd time differentiation, the final answer will be 1. So this answer will be 2009 factorial. So assertion is true. Assertion is true. Now the reason is, f of z has a pole of order 2009. Yes, f of z has a pole of order 2009 at z equals to 0. So why it has a pole of order 2009? So f of z is limit z tending to 0. So we can write this as sin z by z and z to the power 2009. So the limit of g, this is 1. So final will be limit z tending to 0, 1 by z to the power 2009. So this is a pole of order 2009. So reason is also true. So both assertion and reason are true, and R is the correct explanation of assertion. So option C will be correct. The next question is, the function tan of 1 by z has an isolated essential singularity at z equals to 0. The function this has a simple pole at z equals to pi by 4. So z equals to pi by 4, this is 1 by root 2 minus of 1 by root 2. So this is 0. So this is true. The function 1 by z has a non-isolated essential singularity z equals to, at z equals to 0. Z equals to 0 is not non-isolated. This is isolated. So this is false. Now the function sin z by z has a removable singularity at z equals to 0. So this is true. This is true. So option N. Now check the options. D is true. So this will be cancelled. This will be cancelled. C is false. C is false. This is true, false, then true, and option A will be also false. So the function 1 by tan z has isolated essential singularity, but it is not isolated, non-isolated essential singularity. Why non-isolated? Because z equals to 1 upon n, limit point of zeros are non-isolated essential singularity, but it said isolated essential singularity. So this is false. So the correct option will be option B. So our next question is, the value of the integral where C is the circle mod z equals to 3. So the circle is this one, the radius is 3, center at 0, and the integration is taken anti-clockwise. So we have to find this. Now check the singularity. Z equals to 2 is a singularity which is inside the circle, and 4 is outside the circle. So we can take f of z as this. This is our f of z. So the integral will be twice pi I into f of a, f of 2. So twice pi I f of 2 will be sine 2 square means 4, sine 4 pi plus cos 4 pi divided by 2 minus 4 is minus of 2. So this minus of pi I into sine 4 pi is, this is 0, and cos 4 pi is, this is 1. So the final answer will be minus of pi I. So option C is correct. So this is the questions asked in SLET 2023. Please subscribe my channel for more videos. Thank you.